Human brains struggle to process deep time. When we look back millions of years, we tend to compress everything into a single blurry category, an ancient past where every extinct creature seemingly lived at the exact same moment. We can dismantle that mental model by looking at two of the most famous animals to ever walk the planet, the Stegosaurus and the Tyrannosaurus rex. The Stegosaurus lived roughly 155 million years ago. The T-Rex emerged about 68 million years ago. This creates an 83 million year gap where neither existed. Now consider our species. Homo sapiens appeared roughly 300,000 years ago. A modern human holding a cup of coffee is historically closer to a living T-Rex than that T-Rex is to a Stegosaurus. Earth's history exists as a chaotic, layered sequence of entirely different worlds, each one replacing the last in a chronological march we are only beginning to map. Rewinding the clock 450 million years reveals an Earth that defies our basic expectations of evolutionary progress. Because of this formation, an animal during the early age of dinosaurs could theoretically walk from what is now the American Northeast to North Africa without ever crossing an ocean. Atmospheric chemistry dictated the rules of biology during this era, just as much as the shifting land masses. During the Carboniferous period, ambient oxygen spiked to 35% compared to the 21% we breathe today. That chemical shift triggered a biological loophole. Because insects breathe passively through tracheal tubes, this high-density oxygen could penetrate much deeper into their internal tissue cavities. The physical ceiling on insect size vanished. It produced creatures like Meganeura, a predatory relative of the dragonfly that reached a wingspan of 2.5 feet. Biology and geography are never fixed. They are entirely at the mercy of the temporary atmospheric and geologic conditions of their era. We see this volatility again in the Cretaceous period, the age of the T-Rex. This was an era defined by hyper-elevated carbon dioxide. The resulting global greenhouse effect trapped intense heat, forcing a total transformation of the planet's climate. This heat wiped out the polar ice caps. Even with months of total winter darkness, the South Pole supported dense, temperate rainforests and thriving dinosaur populations. Jump the timeline forward again, past the dinosaur extinction, to the dawn of human civilization, roughly 4,500 years ago. In the Old Kingdom of Egypt, workers were dragging massive limestone blocks across the desert to complete the Great Pyramid of Giza. This timestamp captures what was happening at that exact same historical second in the far north. While the pyramids were rising in the desert, isolated populations of woolly mammoths were still alive and walking the Arctic ice on Wrangel Island. Human history and prehistory are not separated by a clean, distinct line. They overlap in ways that defy our intuitive logic. We often view the present as the quiet aftermath of Earth's history, assuming the age of massive biological giants has been over for millions of years. This is Patagotitan maiorum, a titanosaur that pushed the structural limits of bone and muscle to reach an estimated weight of 70 tons. But the blue whale, swimming in our oceans right now, reaches lengths of 100 feet and staggering weights of 190 tons. Supported by the buoyancy of seawater, the blue whale outweighs the largest known dinosaur by a massive margin. It is the single greatest giant in the history of the planet. We are currently living at the peak of planetary gigantism, walking on a fragmented crust in mid-transit between supercontinents and surviving ancient genetic bottlenecks. We are living inside the anomaly, the active, chaotic present of deep time.